All right, one last kind of problem, and we are done with this unit. And that last problem type is the hydrate problem. And what we're doing with a hydrate problem is we're doing the same thing as we did with the empirical formula, but instead of doing percent to mass, mass to moles, divide by the smallest, multiply to a whole, we're just going to do mass to moles, divide by the smallest, okay? And so then it's makes it super, super easy, okay? So, okay, so basically, let me explain also what's happening. So you've got a hydrate, okay, and a hydrate is where you have uh, a sample, okay. You've got a sample of crystal, okay, some sort of crystal, some sort of solid thing, okay, and that solid. Remember, a hydrate is an ionic compound that traps water. So what we're going to do is we are going to burn this crystal, okay? So we're going to put a flame underneath it, okay, and we're going to burn it, okay? And when we do, it's going to cause the water to go away, okay? So the water is going to float up into the air, and it's going to go away, okay? Now, let's think about this for a second. If I have basically a wet solid, okay, and then I heat it up and all the water goes away, is it going to be lighter or heavier than it was originally? Of course, it's going to be lighter, okay? So we can figure out exactly how much water was driven off, and then we can use that to make some calculations, okay? So it says a chemist heats a 300-gram sample of hydrated. That means it's the ionic compound that's trapping the water until all of the water of hydration is driven off. Okay, the anhydrous, which is a fancy term for dry, meaning that we've already driven off the water, is found to weigh 179.7 grams. What's the name and formula of the hydrate? Okay, well, watch what I can do. I can say, okay, well, 300 grams was my sample of hydrated iron 3 nitrate. I'm going to subtract the 179.7 grams so that I can figure out exactly how much water we had. So 300 minus 179.7 equals 120.3. Okay, so I have 120.3 grams of H2O, and I have 179.7 grams of iron 3 nitrate, which is Fe NO3 3. Okay, so I've got my, I didn't have to do percent to mass. Now I've got mass to moles is the thing I need to do now. Okay, so what I'm going to do for mass to moles is I'm going to divide each of these by their molar mass. Okay, the molar mass of water is very easy. It's 18.02. It's one that from here until the end of the school year, you're going to be using a lot. So you're probably, I'm not even going to tell you to memorize it. You're probably going to have it memorized sooner than later, okay? Water, molar mass, 18.02, okay? It's one that you're going to have memorized. So I'm just going to put 18.02 right here, okay? Now I need to calculate the molar mass of iron 3 nitrate. So let me do that real quick. Okay, turns out it was 241.88. So what I'm going to do now is I'm going to do my calculations to figure out what my number of moles is. So I'm going mass to moles. So when I do 179.7 divided by 241.88, I get 0.7429. 0.7429. 120.3 divided by 18.02 is 6.676. Okay, so now we didn't have to do percent to mass. We did mass to moles. Now we need to divide by the smallest. So I'm going to divide by 0.7429 on both. And of course, this turns out to be 1. And this one turns out to be 8.98 or 8.99, which might as well be 9. So let me tell you what this means now. This means that I have 1 iron 3 nitrate, and I have 9 H2Os. Guess what? Times 9 H2O. So what this means is that this is iron 3 nitrate nona hydrate. Okay, so we just figured out that took it way back to unit 7 when we were talking about naming hydrates. Okay, so I would name this iron 3 nitrate nona hydrate. Okay, that's how we do it. I guess I've got time. We can do one more of these problems. It says a hydrate of iron 2 sulfite is known to contain 44.26% water. What's the correct name and formula of the hydrate? Okay, well, if it's oh, good, we do get to do a percent to mass on this one. So if it's 44.26% water, that means it's going to be 55.74% iron 2 sulfite, which is FeSO2. Okay, excuse me, FeSO3. So now I can do percent to mass, which means that I'm just going to change my percent signs to grams. Okay, and now I'm going to do mass to moles. So 44.26 divided by 18.02 and 55.74 divided by, let me calculate the molar mass real quick. So it turns out it was 135.92. So now I'm going to do 44.26 divided by 18.02, and I get 2.456. Okay, 55.74 divided by 135.92 is 0.4101. And now I'm going to divide by the smallest. So divide by 0.4101, divide by 0.4101, and I end up getting 5.99, which might as well be 6 for this, and of course this is 1. Here's a hint. Your water should always be the one that's larger. Okay, if you ever get it to where the water's the small one, or the water ends up being 1, okay, you did something wrong. Okay, water's always going to be the number that's bigger than 1. So now I know that I've got my formula is FeSO3 times 6H2O. How would I name that? I would name that iron 2 sulfite hexahydrate. That's it, my friends. That is it. That's how you do the old hydrate problem. Not to mention that, but that is that's the last of the videos for this unit. So go chemistry.